We are trying to find out any rectangle which should be a contiguous portion with maximum area. For example, let's say if I treat 5 as the minimum height building, think of the extension. Can we extend 5 to the left? Can we take adjoining buildings with 5 and make a rectangle of height 5? No. So if 5 is the minimum height you say, then maximum area, rectangular area we can get is 5. Same way, if 2 is the height of the building we take, can I extend 2 to the left up to this? And 2 can be extended to the right up to 9. Only this much extension can be done. With 2, that area will come out to be 2 will be extended to the left one time, right one time. That area can be maximum 6. Same way, 9 cannot be extended to the left, cannot be extended to the right. So 9, if we have to consider, 9 will be given 9 area. 1 can be extended on both the sides. With 1, what is the maximum area we can get? 8, because 1 will be extended 3 to the left, 4 to the right, 1 itself 8. 5 cannot be extended 5, 2 can be extended. So it will give us 8, 2 can be extended here and here. And 3 can be extended only to the right. So it will give us 6, 6 cannot be extended 6. For every place, if we find the answer, then what is the maximum histogram area that we find? It is 9. 9 is the final answer. Is that correct? Now the point is, if we see when are we able to extend the building to the left side or to the right side? Can I say as long as we see a building less than or equal to or greater than or equal to that length, we can extend it? Do we all agree with that? Yes. That means where the extension will stop, at which point it will stop that we cannot extend. 9 cannot be extended further if I find a building smaller than 9. Same way, 2 cannot be extended here because 1 was smaller than 2. So we have solved the problem of next greater to the left, next greater to the right. And in order to solve this problem, we need next smaller index to the right and next smaller index to the left. Because once we know those two boundaries, we will be able to get to know how much extension we can do. Is that right? This time we need next smaller index to the left and right. So if I just fill indices and manually try to understand the approach, 3, 4, 5, 6, 7. Let's say for every index, we are filling another array. This is next smaller element index to the right. This is NSR, next smaller index to the right. Who is the next smaller index to the right of 5? To the right of 5, who is the next smaller elements index? It is 1. For 2, who is the next smaller index to the right of 2? What is the index of that? Index of that is 3. For 9 bar, what is the next smaller index to the right? It is 3. Let's fill that. For 3 index, what is the next smaller index to the right of it? For 1, value 1, index 3, what is the next smaller to the right of it? It is none. So we will fill the size of the array, which is 8. For 4, index 4, the next smaller is 5. For index 5, the next smaller value index to the right is not there, so it will be 8. For 6, next smaller to the right is not there, so it will be 8. And for this also it will be 8. So next smaller index to the right is filled. 1, 3, 3, 8, 5, 888. Same way, take some time yourself and fill next smaller element index to the left. Fill one more array where you are saying next smaller index to the left, and let me know once you have filled it. For each index, fill the next smaller element index to the left, and if you don't find it, put -1. Okay, so next smaller index to the left of 6 is 6. Next smaller index to the left of this index 6 is 5. Then you have 3, then you have 3, then you have -1, then you have 1, -1, and -1. This is what I am seeing as the answer. -1, -1, 1, -1, 3, 3, 5, 6. Okay, this is what we are getting as next smaller element to the left. Okay, knowing this, knowing that one doesn't have a smaller to the right, one doesn't have a smaller to the left, can we find out the width? How much extension for any building is possible? Using these two values, can we find the extension? Extension is NSR of I for any index I, NSR of I minus NSL of next smaller index on the left is I. Is this the extension we are getting? For example, if I say 8 minus -1, it becomes 9. But 1 can be extended only 8 places. So is this extension or there is any factor with this? Looking at these two values, for example, 5 can be extended to the right or left only 1. So width of 5 we are trying to find out. Overall extension, combined extension, how much we can get. See, for 5, the answer is on the right side it is 5, left side it is 3. 5 minus 3 minus 1. This is the extension possible. Into A of I, if you do, this is the area that I location will contribute. This will be this array. Are we clear? After having NSL and NSR, we can actually calculate this array, and maximum of this array is the answer. Okay, guys. So about stack, if I just summarize, NSL, NSR, NGL, NGR. These 4 functions, if you are comfortable in writing, this helps you solve 4 of these problems, and 5th problem that we talked about is largest rectangular area of histogram. I have seen this question being frequently asked. Next greater element to the left in interviews. People want big of one solution for that. Largest area of the histogram. Okay, NGR is frequently asked. Okay, and I have put up these questions here. Histogram area may take some time to code. So I'm just skipping so that we can go and talk about one more interesting problem, which is good problems. Ravi Teja, I did not got it. What you did not get it?
After we are doing NSR and NSL, what are we checking actually?
Okay, after that we are actually checking how much each bar is contributing to, how much it can be extended. For example, this 2, if 2 was the bar, it can be extended to the left one time, to the right one time. So for this 2, we got answer 6 earlier manually, that if we extend 2 to the left and right, we'll get 6 answer. That manual part you understood, how we manually calculated that?
Yeah.
Now, if you have NSR says it can go up to 3 index, 3 is the boundary of it. Left side, it can go up to -1. That means we said 3 minus -1, -1. So this is 3, this is 3 plus 1 minus 1. This is giving you the width, how much it can be extended. This is telling you the extension formula. 2 can be extended 3 times, so it is 3 into 2 is 6. 9 can be extended only 1 time because 3 minus 1 minus 1. So the difference of these minus 1, this is 2. Difference of these minus 1, 3 minus 1, it is 3. This is 1 and so on. This we multiplied with array A and we got the final answer.
Yeah, understood.